Hello students, today we will talk on force between the multiple charges. Well, we know that force between the two charges is given by the expression that is 1 by 4 pi epsilon naught q1 q2 divided by r square. What happens if there are number of charges are present, multiple charges, more than 2 charges are present, then what to do? How to calculate the magnitude of the force? So it is difficult to find the force on each charge. For that, what we will do here, we will do one thing. If there are number of charges or multiple charges are present, we will find the force on any one charge due to the number of the other charges. And to calculate this, we will use the principle of superposition. Right? So according to the principle of superposition means that if two physical quantities of same magnitude or same quantity are present, then we can add them vectorly to get the resultant. Alright, so here we will find the force between the multiple charges. So according to the principle of superposition, say that there are 3 charges are present like this. I will call this a Q1 and it is Q2 and this is the Q3. I want to calculate the force on charge Q1 due to the charge Q2 and Q3. And suppose that if there are 1, 2, 3 charges are present, there are of course n number of the charges are also present. Qn is the n number of the charges are present. What we will do here, we will find the force on this charge Q1 due to the charge Q2 and Q3. Right? So to find the force on charge Q1, first I will draw the displacement vector from 2 to 1 here. So we get is the R21. Similarly, the force on charge Q1 due to Q3, I will call it as the Q31. Right? So the force acting on charge Q1 due to Q2 is given by F1. So it is F12, it is the force on charge Q1 due to Q2. Similarly, I will find the force on charge Q1 due to Q3. Right? So force on charge Q1 due to Q3 is in this direction because all these are same charges. So I will call this the F13. So that is force on charge Q1 due to charge Q2. Similarly, we have Qn, that is the F1n. So now we will find the resultant of these two forces. Right? So resultant of these two forces is here, we will call this the F. It's called the F. So according to the principle of superposition, right here, according to the principle of superposition, according to the principle of superposition, right here, that is force on any charge due to the number of other charge is the vector sum of all the forces acting on that charge taken at same time. See that. According to the principle of superposition, to calculate the force on the multiple charge, here there are number of charges 1, 2, 3 and n number of charges present. We are calculating the force on charge Q1 due to the charge Q2 and Q3. Alright? So force on any charge, you can take Q1 or Q2 or Q3. What I am taking here is Q1. So force on charge Q1 due to the charge Q2 and Q3 is the vector sum of all the forces acting on that charge due to the number of charges. Alright. So principle of superposition says that force on any charge due to the number of other charge is the vector sum of all the forces acting on that charge taken at the same time. So I will call here and write here the force on charge 1 due to the charge 2, that is F12, is given by what? 1 by 4 pi epsilon naught Q1 Q2 divided by this displacement vector, that is R21 square into R21 cap. Right? Similarly, force on charge 1 due to charge 3, that is F13, is written as 1 by 4 pi epsilon naught Q1 Q3 divided by R31 square into R31 cap. This is the force on 1 due to 2. This is force on charge Q1 due to charge Q3. Similarly, if there are n number of the charges, if there are n number of charges are present, then what I will write here, that is F1n, which is equal to 1 by 4 pi epsilon naught Q1 Qn divided by Rn1 square into Rn1 cap. Therefore, resultant force on charge Q1 is, so F is the resultant force. I am going to say F, which is equal to F12 plus F13 plus up to how much? That is F1. Alright? So this is the resultant force on the charge Q1. So you can calculate the number of forces that acts on the charge Q1 due to the other charges. Alright? So we will say the continuous charge distribution. We know that when we charge any conductor, charges are distributed on the surface of that conductor. Based on that, there are three types of the distribution of charges, the continuous charge distribution. Say that first one is linear charge density, second one is surface charge density, and the third one is volume charge density. Any conductor, when it is subjected to the electrification or charged by rubbing or friction or conduction by means of induction, then the charges are developed on that conductor. And these charges are continuous. We call them as continuous charge distributions. Alright? So there are three types of the distribution. First one is that is linear charge density. Linear charge density. Now what is meant by this linear charge density? If the charges are distributed on the wire, on the line, then we call them as the linear charge density or line charge density. So here, this is a straight wire in which the charges are distributed uniformly. When the charges are distributed uniformly along its length, then we call them as the linear charge density, continuous linear charge density. And we can define the linear charge density in this way. The linear charge density is denoted by the symbol lambda, which is equal to Q divided by L. Q divided by L. Q means charge, L means length. So charge per unit length, charge per unit length is called linear charge density. Linear charge density. Lambda is equal to Q divided by L. Right? Charges are distributed along its length, then we call this the linear charge density or line charge density. Its SI unit is SI unit, charge is coulomb, L is meter, that is per meter. So coulomb per meter is the SI unit of linear charge density or line charge density. Please do remember this lambda, which is equal to Q divided by L, if the charges are distributed along its length. Straight wire scale you can take. Alright. The second one is surface charge density. Surface charge density. Surface charge density. What do you mean by surface charge density? Surface charge density means charges are distributed along its plane. This is the plane sheet now. And if the charges are distributed along its plane, then we call them as a surface charge density. You can see here this board is a sheet. In this way, if the charges are distributed along its length and breadth, then we call it the surface charge density. Surface charge density is denoted by the symbol sigma, which is equal to Q divided by A. Q divided by A. Q means charge, A means area. Charge per unit area. Charge per unit area is called surface charge density. Surface charge density. Right? Its SI unit is. Q means charge, area means A per meter square, that is coulomb per meter square. And the third one is volume charge density. Volume charge density. As the name indicates, volume charge density. You suppose that this is the cube, and if the charges are distributed along its length, breadth and height, then charges are distributed along its volume. Right? Then we call it as the volume charge density. It is denoted by the symbol rho. See, rho is equal to V divided by Q divided by V. That is charge per unit volume. Charge per unit volume is called volume charge density. Volume charge density. Right? And SI unit is simple, that is coulomb per meter. Coulomb per meter. Right? So these are the three types of the continuous charge distribution. One is linear charge density. It is a charge per unit length, that is Q divided by L. SI unit is coulomb per meter. Second is surface charge density, that is charge per unit area. SI unit is coulomb per meter square. And the third one is volume charge density. This charges per unit volume is called the volume charge density. This SI unit is coulomb per meter